Before we start talking about probability, it's really helpful to understand what sample spaces are, which are basically the outcomes for different events. So, a sample space is a collection of all possible outcomes of an event or experiment. Flipping a coin one time is one experiment or event. Actually, I kind of like the word event better. And the coin will land on heads or it's going to land on tails. The two outcomes are heads, tails. Now, this is typically how we write a sample space with the bracket and then the outcome and a comma to separate the other outcomes since there are two possible outcomes when flipping a coin. Now, there are two outcomes for this one event, and since there's only one event, we call this a simple event. And I'll leave it to you to write a definition of an event in your own words. So for the following, determine how many experiments or events occur and determine the sample space. Rolling a fair die one time. That's just a simple event because we're only having one outcome at a time. And possible outcomes are 1, 2, 3, 4, 5, or 6. For flipping a coin, just like we said before, that's a simple event with heads or tails. Spinning the spinner at right is a simple event because I'm only going to get one, and it's either going to be one of these colors, which I just used the initials to denote: red, yellow, blue, green, or white. Now let's go ahead and look at the sum of the rolls of two die. So on the first roll, I could roll a 1, 2, 3, 4, 5, or 6. And on the second roll, I pretty much had the same options. So when I add them, what do I get? I get 2 when I roll a 1 and a 1, and then a 3. And you can start to see the pattern. So here are the outcomes when I roll a 1 on the first roll and one of these other numbers on the second roll. And I continue to fill out the table, and again, you can use the pattern to make your life easier in filling this out. This is not a simple event because you have one outcome and then a second outcome. This is called a compound event. And here are the different outcomes. Notice that 1 is not one of the outcomes because the lowest number I can roll both times is a 1 and a 1, which is 2. So 2 is my lowest outcome. 12 is my highest outcome. Also, notice that not all the outcomes are equally likely. We only have one 12 and one 2, and our most popular outcome is 7. Okay, so a compound event is an event with more than one experiment. Now, let's go ahead and look at the following and determine the type of event and sample space. Flipping two coins, that's two events, so that's called a compound event. I could get heads and heads, heads and then tails, tails then heads, or tails then tails. If I flip a coin twice, is this different from flipping two coins? Oops, I left off my sample space right there. It's the same. It's also a compound event, and it has the same sample space as I have up here. So you can have your sample spaces listed the way I have it here, or in a table, whichever one is easier for you. We can also show sample space by doing a tree diagram for flipping the coin twice. So, and in fact, I love tree diagrams. They're very helpful in determining, especially when you have more than two events. So if I can have two possible outcomes on my first event, which is heads and then tails. Then I'm going to have my second event, which is this column here. So you see that for the first event, when I have heads, these are my possible outcomes. For the second event, if I flip tails on the first one, these are my possible outcomes. And you'll notice that my list is the same as what I had in my sample space before. So when doing a tree diagram, the first set is the first event. The second is the second event, all right? It's not first event and second event. That's the most common type of mistake I see occurring when people do tree diagrams. And maybe it'll be a little clearer with our next example. So we're going to spin each spinner once, and I'm going to put 1, 2, and 3 there, because that's the 1, 2, and 3 there. And then I have the different colors, which I'll put here. So if I spun yellow, then I could have yellow 1, yellow 2, or yellow 3. Same thing for blue, green, white, or red. If I denote this with a sample tree, what we're going to do is the outcomes, the event is spinning one of these spinners. So creating the tree, I'm going to go ahead and do the colors first here. So I'm going to have this one event is spinning that spinner, and there are the possible outcomes. The second event will give me the second column, and I will have outcomes for each color. They're all the same, so it's not that complicated. But sometimes you'll have different outcomes depending on the other. We're not into anything that complicated